So hello students, I am back with the ninth part of the corrosion and its prevention method, and I am your teacher Sudipta Nath. So continuation of the previous video. So this is the third type of the prevention method, which is called as permanent corrosion protection. So over here we see that to provide the protection at the place of use, that is stable oxide layer, which is non-porous film forming metals. So there are various methods of permanent corrosion protection. By applying the film, it may be the similar type of material that we can use in oxide form or in other type of chemical protection that we can give, or we can provide some metallizing agent on the top of that particular metal piece or the alloy piece, so that the permanent corrosion protection can be employed on a piece of metal or alloy. Secondly, the temporary corrosion protection, which stresses occurring during the transport, handling, storage, and much greater than those occurring at the place of use. So extreme variation of temperature, which also results in condensation during the transportation. So these are the criteria which cause the corrosion. So if we can reduce the effect of the stress during transport, handling, storage, and where it was used, so we can reduce the effect of corrosion. Now the fifth point, which is called as corrosion inhibitors. Now what is that? Now chemicals that reacts with metallic surface and gives certain level of protection is called as chemical inhibitors. Inhibitors has chemical bonding with base metal. It is more adherent to base metal, due to which corrosion reaction that stops. So the presence of inhibitors in a saline medium, in a very reactive medium, maybe acidic, maybe basic, maybe alkaline, or maybe very much electrolytic in nature, salt water, etc. If we use a certain type of inhibitor for certain type of medium, then the result is excellent. This is one of the most important figure for the corrosion prevention method, which is called as cathodic protection. Now over here, actually what happens, that during the cathodic protection, certain underground cast iron pipelines, they are protected by means of this method of cathodic protection. So in the second figure, what we can see, that there is a cylindrical pipeline which is buried underground, and the environment at which it is buried, that is definitely saline in nature or reactive in nature or corrosive with respect to the surface of the pipeline, because they are mostly made up of ductile cast iron material. Now when they are externally connected with some type of zinc material, which is placed at a certain point in electrochemical series, and the iron based material, that is ductile cast iron, they are connected together by means of some DC supply electronic circuit, then externally, then after a period of time we will find out that the cathode, that is nothing but this particular pipeline, it is protected and there is no corrosive effect, whereas the anode, which is kept outside, that is the zinc plates or similar type of plates which is kept outside, they are corroded out. So this is one excellent example of the cathodic protection, because time to time if we check that what is the situation of this particular ground bed and the zinc plates, and if we remove those zinc plates and add a fresh set of zinc plates within that particular protecting box, then for a very long period of time the buried pipeline can be protected by means of this cathodic protection or electronic method. And sacrificial anode, that is one more important type of common method which is used in this type of situation, where instead of using zinc we are using magnesium, which is called as anode, and iron pipelines, that is cast iron pipeline or similar type of thing, which is cathode. So by ion exchange and electronic exchange they also will be protected. That is the magnesium, which is quite higher place in the electrochemical series, so they will be corroded fast, and time to time we have to change and check what is the condition of the magnesium plates or magnesium content, and the magnesium will corrode out instead of the iron pipe, although the iron pipe is placed in a very saline medium, but it will be protected, and the magnesium will be decayed or it will be corroded out. And the sacrificial anode method, which over here the anode is the magnesium, which will protect the structure of the iron based cathode. So this is how the major part of the cathodic protection and sacrificial anode method they are employed. So thank you very much up to this particular video, and in the next video, that is 10th video, that will be the final video of this particular set on corrosion and corrosion prevention method. Please stay tuned. Okay, thank you very much. Bye bye.